Great. So my name is Chen, and I am a representative for the Brown Analytics. Today, we're doing a sharing about the marketing strategies for Ads R Us, and mainly our target is to, based on the data set that are given to us, Brown Analytics has done a few data funnel sort of process, including data cleanings, and we have come up with some of the strategies and also recommendations to better help the Ads R Us to have more consumer click rates on their advertisements. So today our journey is mainly based on these 6 steps. So basically data funnel journey explained. Our first step is going to talk about, given the database that are given to us, how we conducted the data cleaning process and what are some of the reasons why we conducted it. The reason to explain this would be, given the database, we sort of want as our us to have this autonomy of deciding what are some of the data points that sort of weights more are more important in terms of marketing strategy decisions, right? So we want to explain this to you, and then the second step would be talking about some of the correlation relationship analysis that we have conducted through this process. And the third step would be some of the more statistically significant tests that we did, and what are some of the results from there. And from there, we are going to talk about, from the chi-square tests and the correlations that we found, what are some of the statistical inferences that we could get from this. And combining fourth step and the fifth step, we're going to make some marketing recommendations on the strategies, which is our ultimate goal, which is, to have a better click rates for our advertisements. And the last step, which is to talk about the limitations of our current, data analysis strategies. And, hopefully in the future, we could enhance our sort of strategy for Ads or Us in terms of data analysis from there. So yeah, let's first talk about data cleaning. So I am going to turn into our Jupyter notebook, which sort of give us a more wholesome view of the stuff that we have been doing. So first off, what we did was to import our data set. I wouldn't really talk too much into this, but this is just going to be, the way that we are doing this, the technical stacks that we are using is PySpark. So we are converting everything from CSV to PySpark, and then we're just reading for the log2.csv, we're just reading it into a data frame. And now this is one of the first steps that we were talking about data cleaning, is to find corrupted URLs. So because we have found that there are sort of asymmetric data points in terms of comparing the product the product CSV and the log2 CSV. So what we wanted to do is to sort of do a mapping to see if any of the URLs are not as synced as the ones that are in the product CSV, right? Because the product CSV on our perspective is more like serves as a template. So want to go from there. And as you can see, some of these like refrigerator, it's spelled wrong and there are some typos. We're going to explain how we conducted data cleaning on this. So this is sort of the algorithm that's behind like how Brown Analytics did the data cleaning process. I'll be sharing this Jupyter notebook with you later on after this meeting. But in terms of, let's just briefly talk about this. So because our URLs are composed of HTTP protocols, it could be HTTP or HTTPS, and then it's contained with the domain name. Here in our case, mostly it's product, the brand's name or the company's name. And then here, this is the router. In our case, as you can see from this sort of table here, even though it's corrupted, we can see like this would be like the company name, Apple, and then .com would be like the suffix for our domain name. And then after the slash, this would be like the router. So yeah, after we got this, what we wanted to do is, because domain name is really important, it signifies which company it is. A lot of the companies have short names. So in our case, Brown Analytics sort of did this opportunity cost analysis, and we found that it is really important to maintain a company's domain name. So in our case, when we're doing the data cleanings, if the domain name or the company name is wrong, then we're just going to delete that row of observation. And then things that are more generic, right? Like the HTTP protocols and .com, if it's misspelled, we're just going to ignore it. Uppercase, lowercase, trailing white spaces, all of these are being processed before we sort of want to fix the URLs. But in terms of the routers, this is where the most significant part works in. So as you can see here, we use a Lavishton score, and we sort of wanted to compare or corrupt the router with the correct router. So we want to see what's the score there. And if it's less than or equal to 3, then we sort of consider it as something that's fixable. So this is the way that we did it. As you can see here, the scores are connected here. So these are the qualified ones. Say refrigerator, it's just a misspelled character. The score is 1, so we could fix it. Washer and gasher, we could fix it as well. Brown Analytics actually did add a new data frame to our as our database, and this is the table that we did. Basically, what we wanted to do was we have all the product types, and within all the product types, we have this mapping of the URLs that are mapped to the say like blender or car or coffee, and then we also have the positive, negative, and neutral sentiments of advertisements and their corresponding click rates on this database. So this is something that's new, and we want to show you this is a progress. And then after all of these sort of analysis that we did, what we want to actually look at are some of the stuff that we did on either the product or the product types, and how with different sort of target audiences or marketing potential customers, what their behavior patterns are like, so that we can inform more about the click rates, right? So with this step, what we did here is basically to compute that for each product. What are some of the sentiments, how the sentiments of the advertisement sort of affected us, right? So basically, if you're looking at this table right here, we're able to see that with Apple computers, a neutral advertisement would have the highest click rates, and we could also infer a lot of information from this. So on the first row, we can already see that for any of these advertisement types, the click rates of the advertisement is actually very inelastic. In terms of our company already has a very good a very good reputation or has very solid products, so that once the users see your products comparing to other products that we listed here, it's very inelastic in terms that either it's negative, positive, or neutral, the user is clicking on it, right? And if we're looking at one more, which could be, let's say, Tesla. So for Tesla, or call them positive, negative, and neutral, we'll go back to Tesla, and we can see that with the positive advertisements, the click rate is actually really low. But for either neutral or negative advertisements, the click rates are more likely to be higher. So these are some of the inferences that you can get from looking at this table where we're basically examining the different products that we have for ads at us, right? So this is one of the correlations or relationship that we found. And then later on, we are looking at the click rates for different product types. So if in terms of marketing strategies for ads or ads, we have limited. So we want to optimize our rate of return, given that we invest a quota of our funds, right? So if we're looking at what product type we want to invest in terms of advertising more, then we could sort of look at this. We could sort of look at this click rates by product types, and we could see that within all of these, what's most sort of what most audiences or potential customers respond to most would be the face cream product type. So it has around 80% click rates on the product on face cream product type. So this would be worth of a investment in terms of advertising, and then we could always rank through all of these statistics and try to see which one is the most optimized or suboptimal decision, right? And okay, now from here we're doing some more of the these sort of click rates to see the user's patterns and behaviors, and we're able to see that for different product types, what are these sort of click rates, and definitely from here we could let's say we just saw that for face cream it's really worth investing the fund for advertising. Then we could look at this row for face cream. We could see that which type of sort of click rates is more worth of investing, right? So we narrowed down to this particular face type, product type face cream, and then we saw that for both negative and neutral advertisements, the click rates are a lot more higher than the positive advertisements. So we could we can narrow down our marketing strategies to these two categories for face cream product type, which have based on our database has the highest rate of return. So now what we wanted to do is to sort of store it into our table. This would just be sort of a database automation, and this screenshot was what I was showing you in the slides. So let's go on with the conditional correlations and the chi-square test statistics that we conducted at Brown Analytics. So what we wanted to do is try to find for the different product types, for different product types, the different sentiments of the advertisements, how these could influence our users, based on their genders, behavior patterns. So let's jump into the results. This is sort of like the result of the table. We have different product types, and for each product type, we have the male click rates positive, negative, neutral, and we have the female click rates positive, negative, neutral. And you could always compare for these in order to find the different behavior patterns. And here we use the PySpark machine learning package to sort of construct the chi-square test and try to see if there's any significance here. So this is our chi-square sort of test statistics that we conducted, and you can see for some of these it's statistically significant, including Blender, right? So for Blender, the p-value is 0.03, so that's smaller than 0.05 p-value, and it's statistically significant. What that means would be, for this particular type product type, the genders different genders behavior patterns on different sentiments of the advertisements for these product types are actually different, and we can infer from here, the ways that we should be doing it. So we saw that these are some of the product types that, let's say for certain product types like gym equipments, right? Also male responds more towards the positive sort of advertisements than females, and all of these inferences can sort of target more towards our marketing strategies. So yeah, we did the same thing for age group, and we did the chi-square testings, where we saw this is basically the supermaster table that we had for the age groups, and then this is the p-values for the chi-square test, and basically we also have some significance here, like for speaker or for perfume. All of these are statistically significant, and we can see that there are actually age group actually does respond differently to different sentiments of the different product types of advertisements. So yeah, basically what we want to look at are for these different tests that we did, some of the marketing strategies that we could recommend to our consumers, to our ads or ads, which could directly influence our consumers. And the things could be, if we're basing on the product itself, then we could look at, for example, what are some of the statistically significant results, how people correspond differently to different sort of sentiments of the ads. For example, for Ford staying, the positive ads are actually more responsive for audiences. They click more. They're more likely to click on this ad compared to the negative and neutral ones. And then for the Maytag dryer, Apple computers, especially for Apple computers, there's a 92%, around 92% click rates if it's a neutral ad. So definitely if we're considering with Apple computer, then we need to target more towards neutral advertisements that be positive and negative comparatively. So all of these tables, we can sort of use the same logic chain and approach to find the marketing influences, right? And then we could also, based on our chi-square test, which is sort of the way that I elaborated it, to find out the influences that we have on these are the statistically significant ones: shaver, speaker, and blenders, to find out what are some of the behavior patterns of our audiences targeting potential customers based on their gender or based on their age group. So this is our statistic for age group, and so for some recommendations that we have here are these are the tables that we saw earlier in the Jupyter notebook. So for some of these we could see that with the male and female sort of reactions to different sentiments of the advertisements, we could target it differently. And also for different age groups, we could also target it differently in terms of, let's say, like for rowing machines, which is like gym equipments, right? So the younger age groups and also like the middle age groups actually responds or prone to click more under more of a positive advertising contest, rather than like senior groups, which actually responds more and clicks more in terms of negative sentiment advertisements for rolling machines. So all these could be conducted on these different data product types and specific products. And then lastly, I just wanted to briefly talk about some of the limitations of our test. One of the most important things is that given the databases, we don't really as of right now we are really not sure where did we get this database. So probably there is a chance that we don't have a lot of information about this pre-experiment sample gathering mechanism. So for example, it could already be the way that we collected these data points and they were biased, so that would lead to a biased conclusion for Brown Analytics. So there are also like some confounding variables. For example, some of the middle values actually has sort of leads to a certain age group to act differently on certain advertisements, and there are a bunch of these confounding variables that could be influencing our results. And this is something that we should be paying attention to, and from in the future we should of course establish a better experiment setting in terms of conducting the chi-square test and other hypothesis testings. But overall, it's a very sort of informative thing, and some of the recommendations, these are some of the recommendations for the way that ads or us could be potentially benefitable or profitable in terms of marketing strategies. Yeah, so thank you for listening today, and if you have any other questions, don't hesitate to contact Brown Analytics. Thank you.